Afternoon all. Now we are discussing the next lecture of point number 5, that is problems on earth pressure. So this is a formula sheet. So the first formula is the coefficient of the active earth pressure at the rest. We know the formula. The symbol is K0. Formula is K0 equal to 1 minus sine of phi. So phi is angle of internal friction. Then coefficient of active earth pressure, that is Ka. So Ka equal to 1 minus sine of phi upon 1 plus sine of phi. Then coefficient of passive earth pressure, that is Kp. So Kp equal to equal to Kp equal to 1 upon Ka, or 1 plus sine of phi upon 1 minus sine of phi. She will take lecture again. Then the coefficient of active earth pressure for the backfill is sloping or inclined. So previously the formula, that is 1 minus sine of phi upon 1 plus sine of phi, is applicable when the backfill is horizontal. So when the backfill is inclined, at that time formula will be Ka equal to cos of delta into cos of delta minus cos square delta minus cos square of phi, that is under root of cos square delta minus cos square of phi. This whole term in under root upon cos of delta plus under root of cos square delta minus cos square phi, where phi is the angle of internal friction and delta is called as a surcharge angle or inclination of a backfill with the horizontal. Means backfill is inclined at an respective angle, that is at an angle delta to the horizontal. So delta is called as surcharge angle. And for passive case, so note that below is the passive case, coefficient of passive earth pressure. This is passive earth pressure. Instead of active, you can write as passive earth pressure equal to cos of delta into cos of delta plus under root of cos square delta minus cos square phi upon cos of delta minus under root of cos square delta minus cos square phi. The same formula for active and passive, but difference is that at the for the active case there will be the minus at the numerator and denominator will be plus. Okay, same like for the first case, that is 1 minus sine of phi upon 1 plus sine of phi for active, and for passive, that is 1 plus sine of phi upon 1 minus sine of phi. Okay, only this difference. Then the next is Rankine's earth pressure for cohesionless soil for horizontal backfill, or we can call it a dry backfill. So this is Rankine's earth pressure for rest condition, when the backfill is cohesionless. So the formula is P0, because P0 stands for coefficient earth pressure at rest, that is 1 by 2 K0 into gamma h square. So K0 is equal to coefficient of earth pressure at rest. Gamma is unit weight of the soil, h is the height of the retaining wall. Then the Rankine's active earth pressure for cohesionless soil with the dry backfill. Okay, next is when the backfill is dry or horizontal. So formula for active earth pressure, that is 1 by 2 Ka gamma h square, which is acting at h by 3 from the base. Next, the Rankine's active earth pressure when the backfill is fully submerged. For the fully submerged case, we have to add the two formulas. First formula is for K gamma dash h square plus gamma w s square. So this formula, it is at base of the wall. If you want to calculate total active earth pressure, so your formula will be 1 by 2 Ka gamma dash h square plus 1 by 2 gamma w h square, where the gamma w is unit weight of the water, and gamma dash is the submerged unit weight, okay, which is given in problem. Then the Rankine's active earth pressure for cohesionless soil with the partially submerged backfill. When your backfill is partially submerged, at that time your formula will be that is there are two formulas. That is first case, that is PA1, that is Ka gamma h1. So h1 is the top height, and h2 is the bottom height, okay, of the retaining wall. Okay, so PA2 equal to K gamma h1 plus K gamma dash h2 plus gamma W into H2 at the base of the retaining wall. So this formula is also for base of the retaining wall. If you want to calculate the total active earth pressure for partially submerged backfill, your formula will be 1 by 2 Ka gamma H1 plus Ka gamma H1 plus Ka that is plus 1 by 2 Ka gamma H1 plus 1 by 2 Ka gamma H2 plus 1 by 2 gamma W H2. Okay. So for then the Rankine's active earth pressure for the cohesionless soil for the layered backfill, when there is 2 backfill, so formula will be K1 gamma H1 for layer 1, K2 gamma 1 H1 for layer 2, and K2 gamma 1 into bracket gamma 1 H1 plus gamma 2 H2. So this formula is for base of the retaining wall, or if you want to calculate the total active earth pressure, your formula become 1 by 2 K1 gamma 1 H1 plus K2 gamma 1 H1 plus 1 by 2 K2 into bracket gamma 1 H1 plus gamma 2 H2. It is the total active earth pressure. Okay. Or you can also calculate the total earth pressure by using this formula, that is PA equal to 1 by 2 PA11. So this is PA11 plus PA2 into H2 plus P plus 1 by 2 PA22 minus PA21 into H2. Okay. Then the next is Rankine active earth pressure when the backfill with the surcharge. Your formula for the base of the retaining wall, that is PAH equal to Ka gamma H plus Ka Q, and if you want to calculate for total active earth pressure for which is acting on retaining wall, okay, so formula is 1 by 2 Ka gamma H square plus Ka into Q, Ka into Q. Okay. Then the Rankine's passive earth pressure, so all are the active theories, now passive theories. So the formula will be same. So instead of you can use PA, you can use PP, and Ka you can use Kp, and all formula will remain same for all the cases. That is for dry backfill, submerged backfill, partially submerged, layered backfill, backfill with surcharge, and sloping backfill. Okay. Only difference is that if you have to remember only formula for active cases, and for the passive cases the difference is that instead of PA, that is active earth pressure, you can write as PP, that is passive earth pressure, and instead of Ka you can write as Kp, that is coefficient of passive earth pressure. Okay. So the Rankine's passive earth pressure, that is for dry backfill, the formula is 1 by 2 Kp gamma H square. So Kp is coefficient of a passive earth pressure. Okay. So then the Rankine's passive earth pressure for fully submerged backfill, so your formula is H equal to Kp gamma dash H square plus gamma W H square, and if you want to calculate the total pressure which is acting on the wall, the formula will be 1 by 2 Kp gamma dash H square plus 1 by 2 gamma W H square, where gamma dash submerged unit weight and gamma W is the unit weight of the water. Then the Rankine's passive earth pressure for partially submerged soil when the backfill is cohesionless. So formula is for, that is PP1, that is Kp gamma H1. All the formulas same like active earth pressure, note that, but only difference is Ka and Kp, Pp and Pa, and so and PP2 equal to Kp gamma H1 plus Kp gamma dash H2 plus gamma W H2 at the base of the retaining wall. Then the Rankine's passive earth pressure for backfill with the surcharge. So at the base, the formula I have writing the formula at the base only, not the entire retaining wall. So formula will be PP equal to Kp gamma H plus Kp into Q. Okay. So Q is your surcharge, gamma is unit weight of the water. So next is the Rankine active earth pressure for cohesionless sloping backfill. Okay, for cohesionless sloping backfill, and below one is below is the your passive backfill. Okay. So formula is PA equal to 1 by 2 Ka gamma h square cos of delta, or so instead of cos of delta, so sorry, here is some changes. So this formula is not cos of delta, that is 1 by 2 Ka gamma h square only, and for passive case 1 by 2 Kp gamma h square. Okay. So these are the changes, you have to write these changes. Okay. So this is not your formula, this is your formula. Okay. That is 1 by 2 Ka gamma h square and 1 by 2 Kp gamma h square. Oh, this formula is also there, but there will be changes in a K and Kp. So your changes in K and Kp as, so K you can directly taken as only this term, so here neglecting this cos of delta. So then this formula I have written this formula you can use, otherwise you can directly use formula, that is 1 by 2 Ka gamma h square. So note that in this case K and Kp as this large formula. Okay. You cannot use the formula that is 1 minus sin of phi upon 1 plus sin of phi, because the backfill is inclined or sloping. Okay. So this is also correct formula, but you have to neglect the term cos of delta while calculating the coefficient of active and passive earth pressure for the sloping backfill. Okay. Otherwise, so for in this case you have neglected, because in above table we had written as, that is 1 by 2 K that is cos of delta into cos of delta minus cos square delta minus cos square delta upon cos of delta plus cos square delta minus cos square delta is whole term. Okay. So you can neglect this term, and if you want to add this term, so for first case while calculating K you have to neglect it. Okay. But if you are taking a screenshot of that, this is the correct formula. Okay. So now we are solving the problems. The first problem is retaining wall is vertical smooth backfill, retaining wall is vertical smooth backfill with the height 8 meter, is support cohesionless soil. Okay. As the soil is cohesionless means the value of C will be 0, and gamma equal to 18 kilonewton per meter cube and phi equal to 30 degree, and the soil surface is horizontal, means the backfill is horizontal. Determine the thrust in the wall. Okay. You have noted that there are two formulas for K. First is for horizontal backfill. So this horizontal backfill, it includes dry backfill, submerged backfill, partially submerged backfill, layered backfill, backfill with surcharge. Okay. For horizontal backfill, all are these cases, that is dry backfill, partially submerged backfill, then the layered backfill and backfill with surcharge. Okay. So for all these cases you can use the formula for Ka as 1 minus sin of phi upon 1 plus sin of phi, and for Kp 1 plus sin of phi upon 1 minus sin of phi, and for when the backfill is inclined, you can use the longer formula, that is cos of delta plus under root of this formula. You know that this formula, what is the formula. Okay. So here is backfill is horizontal, gamma is 18 kilonewton per meter cube and phi equal to 30 degree. So and calculate, determine the thrust. Thrust means the active earth pressure. Okay. So what is the given data? Height of the wall is 8 meter, so h equal to 8 meter. Soil type is cohesionless, C equal to 0, and the soil property is gamma equal to 18 kilonewton per meter cube and phi equal to 30 degree. Backfill is horizontal, that is leveled backfill, and we want to calculate the active earth pressure. So we know the formula for active earth pressure for dry backfill. for the dry backfill, or we can call it the horizontal backfill or horizontal backfill. Your formula is 1 by 2 Ka gamma h square. Okay, 1 by 2 Ka gamma h square. It is the total formula for total height of the wall or total retaining wall. Okay, if you want to calculate only base, the formula will be Ka gamma h only. It is limited only for Ka gamma h. And if you want to calculate for total retaining wall, your formula will be like that. It is 1 by 2 Ka gamma h square. So here the value of K is we know the formula because of backfill is horizontal. 1 minus sine of phi upon 1 plus sine of phi, that is 1 minus sine of 30 upon 1 plus sine of 30, that is 0.33. So by putting the value of K in this above equation, we get 1 by 2 Ka. So Ka is 0.33, gamma is 18 and h is 8 square. So that is 200.64 kilonewton, and which is acting at h by 3, that is 8 by 3 from the base, that is 2.66 meter. Okay. So this is the first problem. Then the second problem, what are the limiting values of lateral earth pressure at the depth of 3 meter in a uniform sand fill if the unit weight gamma equal to 20 kilonewton per meter cube and angle of internal friction phi equal to 35 degree, the ground surface is leveled. Note that once again, ground surface is leveled means horizontal. If the retaining wall with the vertical back face is interposed, determine the total active earth pressure and total passive earth pressure. So here we have to calculate total active earth pressure as well as total passive earth pressure. Okay. So what is the given data? The height of the wall is 3 meter, soil type is cohesionless, that is C is equal to 0, gamma equal to 20 kilonewton per meter cube and phi equal to 35 degree, and the backfill is horizontal. So and required active earth pressure, that is Pa, and passive earth pressure, that is Pp. So once again we know that active earth pressure, that is Pa equal to 1 by 2 Ka gamma h square. Okay. So we have to put all the values, we get the answer. So we know that K equal to 1 minus sine of phi upon 1 plus sine of phi, that is 1 minus sine of 35 upon 1 plus sine of 35 equal to 0.271. Okay. So by putting this value, so Pa equal to 1 by 2 into 0.271 is the value of K, into unit weight is 20, into h is 3 square, so is equal to 24.38 kilonewton, which is act at 3 by 3, that is 1 meter from base. Okay. So this is a total active earth pressure I have calculated. If you want to calculate a base pressure at base, active earth pressure at base only, so you can use only formula, that is Ka gamma h. Okay, you can use only formula, that is Ka gamma h. So here I am calculating the total active earth pressure. So that's why I am using the formula, that is 1 by 2 Ka gamma h square. So likewise you can calculate for passive earth pressure. So there is difference is that 1 by 2 Kp gamma h square. Okay, Pp equal to 1 by 2 Kp gamma h square. So here is also I am calculating for total retaining wall. So 1 by 2 Kp, the value of Kp, so we have to calculate the value of Kp now. So we know the formula for Kp, that is coefficient of passive earth pressure, that is 1 plus sine of phi upon 1 minus sine of phi, or you can directly use Kp equal to 1 upon Ka also, Kp equal to 1 upon Ka also, your answer will be same, that is 1 plus sine of 35 upon 1 minus sine of 35. Okay. that is equal to 3.69. So Pp equal to 1 by 2 Kp gamma h square, that is 1 by 2 into 3.69 into gamma is 20 into 3 square, so that is 332.1, which is act at 3 by 3, that is 1 meter from the base, that is h by 3 from the base. So now we are solving the next problem, that is retaining wall, a 6 meter high, retain dry sand with the angle of internal friction of 30 degree and unit weight of 16.5 kilonewton per meter cube. Determine the earth pressure at rest if a water table rises to top Okay, so note that. So there are two cases. First case, when there is a dry backfill, and the second case, if the water table which is rises at the top of the wall determine the pressure in wall assumed wall. So that assume submerged unit weight of sand is 10 kilonewton per meter cube and unit weight of the water is 10 kilonewton per meter cube. Okay, so there are two cases. So for the first cases, there will be a dry backfill. Okay, so at that time we have assumed that only backfill there is no amount of water on the backfill side, and then for second case there will be the water and to the backfill side. Okay, because this water level which is rises at the top means at the level surface. Okay, so for the first cases the properties are, for dry case gamma equal to 16.5 kilonewton per meter cube and phi equal to 30 degree, and for second case when the water table reaches to the ground level or reaches to top, that is gamma submerged, that is gamma dash equal to 10 kilonewton per meter cube, and sorry saturated, this is saturated, gamma dash equal to 10 kilonewton per meter cube, and this submerged, gamma dash equal to 10 kilonewton per meter cube and gamma w equal to 10 kilonewton per meter cube, that is unit weight of the water. Okay, so now we have to calculate earth pressure at rest, because determine what is the determine earth pressure at rest. Okay, so we know the formula for earth pressure at rest by the table, that is P0 equal to 1 by 2 Ka gamma h square. So now we have calculating for the first case for the dry backfill, we know the formula, it is the entire formula, that is 1 by 2 Ka gamma h square. If you want to calculate at the base only, the formula will be Ka gamma, sorry, here is not Ka, so here is K0, note that here is a K0 not Ka. P0 equal to 1 by 2 K0 gamma h square, it is for entire retaining wall. If you want to calculate only base, the formula will be K0 gamma h. So the value of K0 will be, we know the formula, this is the first formula, that is coefficient of earth pressure at rest, formula is 1 minus sine of phi only, 1 minus sine of phi only. So phi is given as 30 degree na, so 1 minus sine of 30, that is 0.5. By putting the values, earth pressure at rest equal to 1 by 2 K0, once again here there is my mistake, that is 1 by 2 K0 not Ka, K0 gamma h square. So P0 equal to 1 by 2 0.5 into 16.5, 16.5 is the unit weight of the water, unit weight of the soil is given for dry case. Okay, for dry case 16.5, 1 by 2 into 0.5 is coefficient of earth pressure at rest into 16.5, and the height of wall is 6 meter, that is 1 by 2 into 0.5 into 16.5 into 6 square, that is 148.5 kilonewton. Okay, so now if the water table which is rises at the top, so we have to add both the formula, that is for we have to draw two pressure distribution diagram, one is for soil and one is for water. Okay, so the for soil the case, the formula will be 1 by 2 Ka gamma dash h square, and for the second case, that is only for water, pressure distribution diagram for water, so our formula will be 1 by 2 gamma w h square. So once again here is not a Ka, so here is a K0. Okay, it is a K0. So in this problem, when there is a K, you can write K0, you can write K0. Okay, so 1 by 2 K0 is 0.5 into gamma dash, that is unit weight, submerged unit weight of a soil, that is 10 into h, that is 6 square, that is 6 square, plus for the water pressure distribution diagram for water, that is 1 by 2 into 10 into 6 square. So by adding this both the term, so first term is for 90 and second term is for 180, so our answer will be 270. Okay, answer will be 270. So next is, it is for incline backfill, problem is for incline backfill, that is a retaining wall is 8 meter high, is restrained sandy soil, that is cohesionless soil with gamma equal to 1.936 mg per meter cube, not kg per meter cube, that is mg per meter cube, and phi equal to 34 degree if the backfill is inclined at 50 degree to the horizontal. So, the backfill is inclined to the 50 degree to horizontal. Okay, so, this is inclined backfill. Determine active thrust in a wall, use Rankine's condition. Okay. So, the given data, height of the wall is 8 meter, soil type is cohesionless, that is C equal to 0, and the soil properties are gamma equal to 1.936 mg per meter cube. We have to convert into kilonewton per meter cube. So, multiply it by 9.81, that is 1.936 into 9.81 equal to 19 kilonewton per meter cube, and phi equal to 34 degree is given, and the surcharge angle or the backfill is inclined at an angle 50 degree to horizontal. So, delta equal to 50 degree, okay, and the backfill is sloping, and we have to calculate thrust in wall, that is active earth pressure. So, the formula is Pa equal to 1 by 2 Ka gamma h square into cos of delta. You can use cos of delta, but while calculating this coefficient of active earth pressure, we have to neglect this formula. Okay. So, here I am using formula only, that is Pa equal to 1 by 2 Ka gamma h square, 1 by 2 Ka gamma h square. So, the Ka will be cos of delta into cos of delta minus cos square delta minus cos square phi upon cos of delta plus under root of cos square delta minus cos square phi. By putting the value of delta equal to 15, that is cos of 15 into cos of 15 minus under root of cos square 15 minus cos square 34 upon cos of 15 plus under root of cos square 15 minus cos square of 34 is equal to 0.311. So, by putting the value of Ka, so active earth pressure will be 1 by 2 Ka gamma h square. So, 1 by 2 Ka will be 0.311 into gamma, that is 19 is given, and because gamma is 19, na? Right, gamma is 19. So, here is gamma, that is 19, and h is 8 square. So, our value is 189 kilonewton per meter of the wall.